The Kouros, believed to be more than 2,000 years old, is a larger-than-life figure of a Greek youth. The designer of the statue's base is seismic engineer Jack Yagubian.
The specific challenge with the statue is the fact that the statue is very unusual because it has a very heavy torso compared to the size of the ankles. And when the statue was discovered, it had fractures at the knees and at the ankle. So any earthquake vibration could transfer to the ankles, and because they're very small, and that will be the very first place that it will break. From that viewpoint, we had to design a system that absolutely no vibrations from earthquake would be transferred to the statue at all.
Soon after successful testing of the base isolation system for the Getty showcases, I was shown 7 fragments of a marble dolomite statue later known as the Getty Kouros. Similar to conservation and earthquake protection of Getty Pride's statue Heracles, Getty Conservation Department was planning to assemble the broken pieces of Kouros utilizing large diameter bars and glue and anchoring it to the floor. To me, the Getty Museum's earthquake protection practices lacked intelligence. I had different ideas.
We had to come up with something very innovative to put the thing together without using very large size bars that would require drilling major holes and removing a lot of material. So the system is what we call a post-tensioning, which was used in construction and civil engineering before. That was really the concept that we utilized for that.
In a written report to Getty, I recommended mechanical joints be developed by pressing the fracture faces of the fragments against each other by means of thin tension cables, and if necessary, the stability of mechanical joints could be further improved by means of introducing shear pins. To demonstrate the feasibility of mechanical joints for Kouros, I drilled a small hole through the entire length of a 4-inch solid log. To model Kouros's fragments, I made several crosscuts through the log that made it unstable under load. The integrity of the log was restored by inserting a long, threaded rod through the center hole and tightening it at both ends by 2 wing nuts.
The future earthquakes are going to be pretty severe, and the ground motion, the ground will be moving about a foot, about 4 times every second. And for Kouros to survive such a thing, we just had to come up with something innovative so it can withstand the earthquakes and it won't get damaged. The base isolation system is really a very simple device. It reduces the friction between the statue and the floor, which usually that's what causes for objects to rock or tip over. And we added another device that would bring it back to its original position.
The assembly of Getty Kouros, as I had specified, commenced by the Getty Conservation Department. In horizontal position, small diameter holes were drilled from the base of the plinth to the middle of the thighs. Stainless steel aircraft cables anchored in the thigh were extended to a thick aluminum plate attached to the bottom of the plinth. Attached to the aluminum plate were post-tensioning winches and load cells to apply and maintain my designed incremental loads. To monitor the response of the marble to the applied compression loads by the cables, stress strain gauges and geophones were attached in the vicinity of the fracture joints. Throughout the entire load application process, I was monitoring the actual applied incremental load readings and compared the readings to my calculated allowable stresses in the marble. The statue and its cage were anchored to the blue base isolator. The Getty technicians, ever so carefully, began loosening the front panel bolts. The technicians' body language was telling me that they were unconvinced that the statue would remain standing following removal of the cage. To assure them that everything was just fine, I helped them take away the front panel and gestured the rest of the cage be removed. For the first time, the Getty Kouros was standing without any external support as I had conceived. I was pleased to see my engineering contributions to the art world. Getty Curator of Antiquities, Marian True, walked in the conservation laboratory and was surprised to see the Kouros in an upright position for the first time and began to study the statue from all sides. At the conservation lab, I had this snapshot taken for posterity that shows full circle of the mechanical joint, conservation and earthquake protection system that I had devised for Getty Kouros. On the eve of exhibiting the Getty Kouros, I was invited to join a gathering for Getty staff hosted by museum's director John Walsh. Standing in the center is Curator of Antiquities Marian True. Few weeks before the Getty Kouros went on exhibition, rumors regarding authenticity of the Getty Kouros began to appear in major newspapers and magazines around the world. The issue of authenticity surrounding an art object is never a factor in the challenge of engineering the conservation and earthquake protection of antiquities.